We're going to be looking at some characteristics of these graphs and trying to identify the values of k and p in these functions. So I've written up some hints over here to kind of help us determine what our value of or our k value is going to be and our p value is going to be potentially. So the hint is the k, the leading coefficient, if it's a positive number, that's what greater than 0 means, then you should see part of the graph in quadrant 1. And quadrant 1 is always up in the upper right-hand corner. So if I don't see any part of my graph in quadrant 1, then k must be less than 0. For part B, the power p less than 0 or greater than 0. So what that's asking is the power a negative number or a positive number? If it's greater than 0 or positive, then it's going to be continuous. In other words, there's no break in the graph when you go to trace the graph. But if p is less than 0, you're going to have a definite break in the graph. And as for p being an even power or an odd power, for example, a squared versus a cube, that's going to be also identified in the picture. Some students like to look at it as the ends are going in the same direction for even, but it also has y-axis symmetry. So if I find the y-axis and I can fold over the y-axis, p is even. I can also look at it and say, well, do I have split ends? The ends going in opposite direction. That's true, and it also exhibits origin symmetry. In other words, opposite quadrants are going to look the same. So in working through these problems, we're going to identify or answer A, B, and C here. And we'll start with question number 1. So the coefficient k less than 0 or greater than 0, well, again, that goes back to, is there a picture of my graph in quadrant 1? So if I go through here, there's no picture in quadrant 1, so k must be less than 0. So let's go through all of these. For this one, I do have a picture in quadrant 1, so that means my k is greater than 0. Coming down here, no picture in quadrant 1, k less than 0. I do have a part of my graph up here, so k greater than 0. And remember, k is the number in front of my function. No picture here, k less than 0. I do have a graph here, k greater than 0. And it's looking like this one's a k greater than 0. And k greater than 0. Okay. So it's just a matter of looking, do you have anything in the first quadrant? If you do, k is positive. If you don't, k is negative or less than 0. All right, now we're looking at our power. P less than 0 means that would be a negative exponent, which would drop that x down to the denominator. And when that goes down to the denominator, x can't be 0. So we'd expect a break in the graph if p was less than 0. That's what we mean by break in the graph. If p is a positive number, a positive exponent, then the function is going to be continuous. So we'll go through and identify p now. So for this one, there's a break in the graph, p less than 0. Our power would drop that. It'd be a negative power, which would drop our x down into our denominator, and we can't have x be 0. This one is a continuous function, p greater than 0. Right, another continuous function, p greater than 0. As long as you can draw the graph without picking up your pen, p is a positive number. So we have another positive number for power. Here we have that break at x equals 0, so our power must be a negative number, p less than 0. And for the next two here, we also have those breaks in the graph. I can't draw it without picking up my pen and starting again, so that's not continuous. P less than 0. Okay. Now we can go back and do part C, determine if the power is even or odd. And again, probably the easiest way is if it's even, we should expect y-axis symmetry. If it's odd, go with the O's, origin symmetry. So for this one, if you can fold over the y-axis, it's even. So another fold over the y-axis, it's an even power. Right, between these two, I have one that's even because I can fold it over the y-axis and it will lie on itself. But this one, if I fold it over the y-axis, it's not going to lie on itself. It's in fact across the origin that we have the similar graph. So this one, P, is an odd number. All right, this is again another one that's not origin, or this isn't y-axis symmetry, but rather origin symmetry. So this would be odd. Here's another origin. It'll flip across and lie right on top of itself. So for this one here, I can flip it across the y and it'll lie on itself. So it's an even number for our power. And this one would be flip across the origin. So P is odd.